Okay, classical probability. We're going to begin with the general addition rule, which is the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B, or A and B. Please note, while you don't have to memorize this formula because it's on the formula chart, the key thing is this formula is good for any time they're asking you to combine something, whether it's independent, mutually exclusive, or neither. You need to make sure that you understand that U means union or summation, or A or B or both. The N for intersection, and means and, intersection, both, and this is a conditional or joint probability. So mutually exclusive events are events that cannot occur at the same time. So in this case, if I had two circles, that shows that do not overlap, they share nothing in common, that's mutually exclusive. So we have this problem, given probabilities A equals 0.4 and A union B is 0.6, what's the probability of B if A and B are mutually exclusive? Well, so A union B equals the probability of A plus the probability of B minus the intersection. That's just the general addition rule. I plug in 0.6 and 0.4, and then I plug in 0 for the intersection because it's mutually exclusive, and there can be no intersection if they're mutually exclusive. Then I solve. If they're independent, and put a big star, if independent, this is only if it is true if independent, the intersection equals A times B. So they asked me to calculate the problem if they are independent. And since that's the case, I can substitute this for the intersection sign, which I did here. So now I have A union B equals the probability of A plus B minus probability of A times B, and I can do that because they told me they wanted me to assume that they were independent. In which case, I plug in my values and solve. Please note, this is where people get confused. 0.6 minus 0.4 gives me the 0.2, but I have 1b and 0.4b. Well, 1b minus 0.4 is 0.6. I divide and I get 0.3, or actually 1/3. Okay? Independence. Once again, if independent, the probability of A and B equals the probability of A times B. Also note that the probability of A given B equals the probability of A if independent. Please note that. Make sure you understand that that means given, and given is in the denominator. This is not a fraction line. It just tells me given's in the denominator. So A given B equals the probability of A. A given B equals the probability of A intersect B over the probability of B. All right? These problems can be found in your note spiral. There is and you need to be able to work those. Please remember, segmented bar charts will have sections that are exactly the same size, or if they are independent. If they're not independent, they're different. Also, you need to keep in mind that if you have a table of values, and the tables are proportional, not the same value, but the ratios are proportional on the table, then they are also independent. There's a problem in your note spiral, and I do not remember the page number, maybe page 76, I'm not positive. Actually, it's later than that. That has to do with left-handed and right-handed. And those variables are independent, and they are independent because, and we know that because they are proportional. You are going to need to know that for the exam. So make sure you understand that if a table has proportional values, then the variables are independent. You're going to need to be able to calculate marginal frequencies and proportions from a table. I'm going to come back and do that, so we'll pause this right now.